All right, come on in. I think that is everyone from outside. So welcome to Cloud Native London. This is the first meetup of the year of 2024. And I'm really pleased that you've all come out tonight because it was so cold today. I thought, what if everybody wants to stay at home instead? But yeah, well, I'm extremely happy that all of you have come out tonight. So we are a strong, open, diverse developer community dedicated to the cloud native platform and technologies in London. I'm your host for the evening, Cheryl Hung. You can find me on Twitter at @OiCheryl. I'm previously of Google, Apple, and CNCF, currently now work for ARM. Tonight, we have 3 speakers. So our first talk is going to be Quickwit's cloud native logging and distributed tracing. Our second talk is going to be about 3 pitfalls everyone should avoid with cloud native observability. We'll take a break at 7:45, come back at 8 o'clock for our last talk, Transcending Microservices Hell for Supergraph Nirvana. And then at 8:30, we will wrap up and we will go to the Conductor pub downstairs if anyone wants to have a bit more conversation. Please do return these badges as well, I've been told. If you haven't got one, these are the ones that let you in and out of the door, but we have to return them when we leave. Thank you to tonight's sponsors, Sysdig. Is anyone from here from Sysdig who wants to do the intro? Okay, if not, I'm going to read it out for them. Give me a moment to find it. Sysdig. Sysdig is driving the standard for cloud and container security. With Sysdig, you can prioritize software vulnerabilities, detect and respond to threats, and manage cloud configurations, permissions, and compliance. Your teams get a single view of risk from source to run with no blind spots, no noise, and no black boxes. So thank you very much to Sysdig. Okay, a little bit about you. So please grab your phones and go to this link, oicheryl.com. We're going to do a bit of live polling. I'm going to ask you 2 questions about yourself and then 3 questions about how you use cloud native, which have been submitted by our 3 speakers for tonight. You don't need to download anything. It'll just link you to this poll everywhere service. So that's oicheryl.com/p. There is a longer link if you don't get this one. So first one, okay, people are already on it. Is this your first time at Cloud Native London? So you should see a yes and a no. You just tap. Looks like we're getting quite a few. Oh, very equal, very 50-50. Maybe even a handful more yeses, which is awesome. I love having new people here. If this is your first time, then I'm glad you found us and welcome. Just give another minute or 2. We're also live streaming to YouTube and to Twitch at the moment. So there might be people who are joining us from home and answering the live poll. What was the link? It's oicheryl.com/p, or you can do this longer one, polev.com/cherylhung, blah, 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 blah. All right. I'm going to move on. I think there's still a few people figuring it out, but let's keep going. What's your job title? So pick something that's closest to what you do. Your options here are architect, application developer, backend developer, engineering manager, SRE/DevOps engineer, security engineer, or anything else. It looks like we got a pretty good split. We've got a bit of representation from everybody today. 30% SRE DevOps winning, bunch of others. Nice. Okay, let's go. So first question from our speakers. Which storage backend are you using in production for your distributed traces? Elasticsearch, Grafana Tempo, Cassandra, or something else? I think this was from Francois. Where's Francois? Okay, excellent. So what do you think of these results? well, actually 40%, nearly 50% of people are saying other. So if you said other, can you shout out what you do use? Core logics?
Sometimes you don't speak of others.
You don't speak of others. Is this what you expected? Like mostly Elasticsearch and yeah. Oh, okay. Amazing. Well, we're very representative then, which is good. Are you comfortable as a developer or SRE with your cloud native observability tooling? Yes, no, maybe. What's observability? What's a developer? What's an SRE? um, I think this was from Eric. That's your question. So what were you expecting here with this question? More laughter? It's a good question. 33% yes, 10%, 11% said no, 29% said maybe. A bunch of people who not sure. You want to know what SREs think? Okay. Okay. Still a few people deciding what they want to vote for. Well, I'm sure that you're going to go into this a little bit more later during your talk. All right. Next question. Do you know GraphQL and do you use it in production? So I have not heard of GraphQL. I've heard of it, but I've not learned how to use it. I know GraphQL, but I do not use it in production. Or yes, I do use it in production. So where is Tom? Tom. Okay. So what were you expecting with this? Is this is positive? This is more positive than the next one's going to be. Okay. So 9% said they've not heard of it. That's 90% of people said they've heard of it. That's pretty good. 45% saying they don't use it in production. Then have we used it in production? Okay. I thought this was the last question. Yeah, I don't know if you had another one. Okay. Sorry. Okay. Well, you can mention what was your next question later. Okay, I need a selfie. So I need everyone to smile and wave. I don't know how I'm going to do this. This room is too long. I'm going to have to stand in this corner, I think.
Remind me next time to get a really nice hat for me.
A really nice hat. Oh.
Yeah.
Everyone like, okay, smile and wave again. Thank you. I need a selfie stick, exactly. All right. If you want to come and speak at these events, or you want to sponsor, help pay towards the pizza and beer, or you have your own events that you want to promote, then go to cloudnativelund.com. You get all the information there. If you do want to speak, we're now booking up for Q4, so just plan ahead a little bit. And that's it. So I'm now going to hand over to Francois, our first speaker. Yes, please, round of applause.
Okay, you can share.
Good.
Okay. First question. Nice to meet you all. I'm very happy to be here. There's a lot of people, so I'm a bit stressed, but I hope that my demo will work. Who knows already Quickwit? 2, 3. Okay, great. Of 4, 5 people. So that's not a lot. We released recently a new version, and we made a lot of communication. We were on the front page of Hacker News, so it was really great. I hope that more people will know us tonight too. So who am I? I'm one of the co-founders of Quickwit. We started 3 years ago. I'm a core developer on the engine. Quickwit is a distributed search engine, kind of Elasticsearch, but for observability only. I will explain you why it's for it works well for observability and not for other use cases. I worked also on the Grafana plugin because we integrate Quickwit in the open source ecosystem. And I have a background, like I have been programming for more than 10 years in Java, Python, and like these last 3 years, I coded it mostly in Rust, which is a great language, by the way. So tonight, I'm gonna talk a bit about the 2 main open source tools used for observability. And you know them already. And I will explain you what is Quickwit, how it is different. And then I will show you a quick demo of Quickwit on distributed tracing. So first, what are the most well-known observability engines in the open source world? So you talked about Elasticsearch previously, but Elasticsearch changed its license recently. It's no more an open source license, so that's why I put OpenSearch, but it's a fork of Elastic. As you know, in observability, you have to handle 3 signals, metrics, logs, and traces. I guess you know all those signals. And OpenSearch and Elasticsearch can index those signals in their engine, and you can do some search analytics on it. Then it works primarily on SSD. So you don't put your data on an object storage, for example. To be fast, to be performant, it needs to be on SSD. OpenSearch as a search engine is working with an inverted index. So it's great to find the needle in the haystack. And the user interface is Kibana. It's called today for OpenSearch Open Dashboard. It's a fork of Kibana. But that's the stack commonly used for observability with OpenSearch. Then you have Grafana suite, which is well known. I can see it in almost every company, at least for the dashboard part. They developed 3 engines to handle the 3 signals. Grafana Mimir, it's a combination of Prometheus and Mimir. Mimir is for the long-term storage. Loki is for the log. So it's the engine that will store your logs. Tempo is the engine that is storing your distributed traces. And what is interesting here is that it's working on object storage. And object storage, like it's today something that is used everywhere. Every cloud provider is proposing its own object storage. And you all know that this storage is very cheap and very safe. So that's why it's very interesting to put all your, if you have massive amount of data, you want to put it there. And it scale, obviously. One particularity of all these engines is that they are mostly index-free. I said mostly is that, for example, in Loki, you can say that they are indexing labels. So if you search your logs by labels, it will be fast. But when you search in the text of your log, It's not indexed. So here it will have to scan all the text to find what you want. So it's not indexed. This part is not indexed. And of course, like the user interface part is Grafana. So how Quickwit fits in this picture? Quickwit, as I said, is a search engine. So that's why there is this inverted index. We don't do currently all those, we don't handle all those signals. We only take care about logs and traces. We plan to do metrics later this year. We store everything on object storage. So we have the same approach as Grafana here. And I will explain why it's super efficient to do that. And we integrate well with, we have a Grafana plugin. So you can use the Grafana user interface, Grafana dashboard or Explore view with a Quickwit. And we plan to support Open Dashboard too this year. So to summarize, as Loki and Tempo, Quickwit store all its data on object storage. The difference is that we have an inverted index, so we need to be fast for the search part. And as in Elasticsearch, so we, as I said, we have this inverted index, and we have also columnar storage, so for the analytics part. So let me explain you a bit how Quickwit work. What does it mean when you put your data on object storage? It's the same for Tempo and Loki here. I put the object storage in the middle because to show that it decouples the compute and the storage. So the compute first on your left is when you ingest your data, you receive a bunch of logs, a bunch of traces, you have your JSON, and then you have a process. Quickwit call it an indexer. It can be an ingester, compactor, if you need to compact your data, small files in bigger files. So Loki has the same concept. It will take it, write it on the local disk, and upload the file on the object storage. The nice thing here is that once it's on object storage, all your search compute can fetch it. So you can totally decouple your indexer, your searcher. So it's very, in terms of architecture, it's very flexible. The hard part, of course, is that now you put your data on this object storage, but it's slow. So you need to take care of that. So as I said, you separate compute and storage. So you gain in terms of elasticity. You decouple your indexer, your write request, and your search request. So for example, if you want to start 10 indexers, you just start them and they can be useful every 10 seconds later. It's the same when you want to scale your search, because if you take the example of Elasticsearch or Cassandra, when you start nodes, the first thing that you will have to do when you start a new node is that you need to move data to your node. But when you separate compute and storage, you don't have to. You just fetch the data on your object storage, and that's it. So in 5 seconds, you can have a searcher that is up and running. And this is the same for Loki or Tempo. Then, like what we did at Quickwit, because the difference with Loki and Tempo, which are also on object storage, is that we kept the inverted index, so that we can find very fast, like for example, all the logs of one user ID, all the traces for one user ID, for example. We can find it very, very fast. So we worked on the data structure of the index to optimize the number of requests that we make on the object storage. You have to keep in mind that when you have a local SSD, one read request is taking 1 millisecond maximum. And if you make a request on an object storage, for example, Amazon S3, it will take at least 70 milliseconds. So if you do 10 reads, it's done. You can't do that. So in Quickwit, we optimized it so that we can do a search request in maximum 4 consecutive GET requests on the object storage. So we had to review completely the way the inverted index is structured in Quickwit. So that's what we did, and that's why Quickwit works great. So we can be subsecond most of the time. If you have a big query, and I will show you, it will take longer, of course. One other thing that is different with Elasticsearch is that we are more efficient at indexing. I think many users of Elasticsearch were complaining about the compute cost, the fact that it takes time to index. You need to know that when you send some documents into Elasticsearch, usually you have a primary shard and a replica shard. The primary shard will receive the document and will index it. It will also send this document to the replica, and the replica will also index it. So if you have one primary, one replica, you will index the logs twice. So this is costly, especially when you have a lot of data. For a small website where you don't have much documents, that's okay. But for logs, when you have terabytes of data, this is costly. So we avoid that. And the other advantage of Quickwit here is that it's written in Rust, and we are based on a library called TonTV, and it's very optimized. So we use SIMD instructions. We avoid allocations. We try to optimize also allocations so that we are very fast. So we are twice faster than Elasticsearch on this part. So if you don't index twice the document, and if you are twice as fast as Elasticsearch, we have a factor of 4 just on the indexing part. And last is that we can be schemaless. So it's very practical for observability data, logs, and traces, because you can have a lot of fields. You don't know in advance the JSON structure of your documents. So I will give you 2 examples, and then I will show you the demo. It's 2 examples coming from our users. So here, it's a user that has 14 indexes, so 14 pods on Kubernetes. It's Graviton instances. I don't remember the exact name of the instance, but whatever. Generally, on indexers, you can give like 4 CPU to each indexers. You need a little bit of RAM, so we are quite optimized on this part. And here you can index like something like 46 terabytes per day with only 14 pods. This is so this user divided by 5 is compute cost compared to Elasticsearch. This is another example from another user, which is also very interesting. A common use case when you have a lot of logs and you want to index it, you want to have a buffer. Generally, you use a distributed queues for that. Well, some users use that. And here I'm showing like the size of a queue on one topic in Kafka. So Kafka is nice to have it in front of your Elasticsearch because it takes time to index logs. So if you have a huge spike, a huge spike, Elasticsearch won't be able to index them at once in 1 minute. So you use it as a buffer. And here, like they had one big spike of 1 billion of documents, 1 billion logs. It's mostly access logs here. And they index that with Quickwit, and they decided at this point, at the peak, they decided to start between 20 and 30 nodes indexers of Quickwit. And in 20 minutes, it consumes every logs that was in Kafka. And at 20 minutes later, they just stopped the 20 pods that were started just to index these billion logs. So the advantage here is the flexibility. You can start 20 indexers and then stop it 20 minutes later. Okay, so now I can show you a demo. So what I prepared for you, let me check. I have 10 minutes. So I'm connected to a Kubernetes cluster. Do you see it or should I zoom? So I'm showing you only part of a cluster, the indexer part and the searcher part. So when you deploy Quickwit on a Kubernetes cluster, you will see mostly two stateful sets, the indexer stateful set and the searcher stateful set. So here I have only one indexer. So if we look at the pods that are present, you can see, let's forget the control plane and the other pods. You have one indexer and 3 searchers, right? So great. That's the Quickwit cluster. And now I will show you what's inside this Quickwit cluster. So here I'm on one index. This is the index that is storing traces, and to be exact, spans. So here, as I played with it a bit yesterday and this week, we have 2.5 billion spans on it. So here I'm not doing a request. So everything is stored on the object storage. So that's if I want to shut down the cluster, that's fine, and I can start it again. The size of documents is it's 2 terabytes, so it's not that big. It's uncompressed, and the compressed part here is only 300 gigabytes. I can show you a bit what's inside the type of document in this index, if it's working. Sorry. The cluster is in the United States, and sometimes I have some disconnections. Okay. So here I'm just port forwarding the searcher so that I can make requests locally. Okay, cool. So here I'm hitting 2.5 billion of traces. I have only 3 searchers, so it will be slow because we did not optimize this stupid query because we are requesting everything. But at least Quickwit is answering. So it says he has found 2.5 billion traces in 11 seconds. So if I want, I can speed up this kind of query. But what we can do here is maybe target one specific span ID and say, hey, I want span ID this number. I will show you that in Grafana after what. Okay, so here you can see the efficiency of an inert index. If you are looking just for the span ID, we will be subsecond with 3 searchers on 2.5 billion document. So this is great. We can, if we want, what I wanted to show is to also to add some new stuff. So we have this dashboard, which is based on the Prometheus metrics that are exported by Quickwit. So here we can see that we have one indexer. This indexer is taking 300 megabytes in RS in a resident memory. It is indexing something because here I'm sending Quickwit traces in Quickwit so that we can observe Quickwit cluster with Quickwit. but we don't send a lot of them, so that's not very interesting. So what I will do is I will use a tool called Transcending. I think you should know the tool called Jaeger. I'm sure you know it. And they developed a tool called Transcending that is generating fake spans, but it can generate a lot of spans. So that's interesting. For that, it's for stress testing your tool. So that's what I will do. I will generate a lot of them. Maybe here. There. Where is it? I lost my tab. Okay. Okay. So here's the job that I will create on the Kubernetes cluster, and it will just execute the trace-gen program to send some traces into Quickwit. So Quickwit supports OpenTelemetry protocol, so we can use the gRPC endpoint or the HTTP endpoint. So I will just create. So while it is starting to send some traces, I will do something else. So what I will do is, as I want to index a lot of traces, I want to scale my indexes. So we will add, I have a bunch of nodes on this cluster. So I can start, if I want, 10 indexer. So they will be ready pretty soon. So here, they are up and running. So now I should be able to send more traces. So I started only one job that is sending traces. So here you can see that we are indexing at 20 megabytes per second. That's not a lot. Still, with at 20 megabytes per second, you can index almost 2 terabytes per day. So that's already nice. It's already quite performant. But we can add more, and I will create another job to send more traces. So I can't remember how many. So here it's the same job, but I asked to start 60 jobs like this. So hopefully it will work. So I will refresh it because to take into account like other indexers. So here we can see that we have 10 indexers, and we will wait. Okay, so here you can see the throughput, or yes, you can see it. That's okay. So just to show you that it's pretty easy to scale up your cluster and index a lot. So at this speed, you can index, I think, yes, so 10 more times, like 20 terabytes per day, 25 terabytes per day. So that's cool. So that's for the index part, sorry. I can show you now the Grafana plugin part. I will delete this because I will need more searcher. And what I will do now is that I will scale down my indexers to 1. So everything is terminating. And then I will increase my number of searchers because I want to do some aggregation, some analytics on billions of traces, so it costs a lot, and I will need more searchers. Sorry? On the 2.5 billions of traces. Well, yes. So yes, if I start 10 searchers, it will use the 10 searchers. Unless you are only request, like we have a small unit called a split, and your index is made of several splits. So it's a file on the object storage, and it's the unit of work of the searcher. So if you have only one split, you will have only one searcher that is working. So okay, we have our 10 searchers, and then we can do something. Okay. So this is I'm using here the Quickwit Grafana plugin. So it's the same as the Elasticsearch one. So you can define some aggregation matrix. So for example, here percentiles. You can do some term aggregations. So here I'm doing some aggregation to know which span name is in my index. And usually when you what you want to know when you have traces is you want to know which operation is taking some time. So it's always nice to know what's happening on your cluster, for example. So here, TraceGen is a bit stupid. It is generating a lot of child span 55, so it's not very interesting. But this example is just to show you that it can scale. So I can run it on a on a lot. So I'm running here. Okay, maybe it's not working anymore. Okay. Did I lose my Grafana? Shit. Wait. Let's reduce the number of hours. Okay, so I guess there was a problem at 24. So here we are doing like huge aggregations on billions of traces, and that's why it is taking time. So it's not exploitable, as I said, because Grafana TraceGen, the TraceGen tool did not sending some very understandable trace. So that was for this part. I don't know if I have the time to. I should close 5 minutes. So if it's possible to do something that is more understandable than this, because here it's only to show you that it can scale. So I prepared a dashboard that is more useful. So the dashboard I prepared is made with a Grafana plugin. I need to shut down everything. So it's a small demo. It's a small demo that is starting one fast API of web services. And I simulated a bunch of requests on it. And then all the traces are sent into Quickwit. I can. I will show you the Docker Compose YAML to show you what I'm starting. So I'm starting a fast API service, so it's just a web service with a bunch of endpoints. There is also like the same thing, but with Spring Boot. And there is an open collector that is retrieving the traces from those applications. And this open collector is sending traces into Quickwit. And okay, I'm almost there, almost finished. Okay, so I started a Grafana instance and I prepared like a small dashboard with some data. So I won't send more data now, so I will take the one I sent earlier today. So here, what I want to show is that if you send your distributed tracing in Quickwit engine, you can also do some application monitoring dashboards. So it's not only finding a needle in the haystack, for example, a span ID or whatever, but you can do some interesting like dashboards to know what's happening in your application. So here, for example, you can draw the average latency for each HTTP endpoint of your applications. And inside, like it's the same type of query I showed you before. So this time it's an average, and I'm doing a term aggregations on the span attributes. So a nice thing here that I can show you is that you have access to all the attributes of your spans, and everything is dynamic here. So you don't have to specify those attributes. It's dynamic, so we scan everything in Quickwit, and we ask. So to display this list, we make a GET request on Quickwit that is returning all the available fields that you have in your spans. I think that's it. If you have questions, yeah, I'm listening.
There's actually a question that's come through the live poll, so I'm going to take over screen share.
Yep.
Okay, so question is, how easy is the migration path from Elasticsearch?
That's a good question. So Elasticsearch API is huge. So obviously it will depend on your usage of Elasticsearch. Currently, we support several endpoints. We support the main Elasticsearch API endpoint. We support the aggregation DSL, the query DSL. We like pagination, we support it too. But if you use, for example, Open Dashboard, we are not compatible yet. Like you can't plug Quickwit, your Kibana on Quickwit, it won't work. It will use many endpoints. So this is planned for this year, but this kind of migration will take time. Do you have a way of showing the estimated the cost of a query before it's run? Yes, this is a very relevant question. Yes, so it depends on the size of your data set. If you request, it's not obvious to compute it, because the S3 cost, it depends on the number of GET requests that you will make. So we do some put requests, but put requests are okay. That's negligible. So you have to be careful on the GET request. If you have, for example, an application with a lot of QPS, this is a problem. Generally, we say if you have more than 10 QPS, you have to use some caching on the local disk. So we have a feature that was just released a few days ago that allows you to cache some data on the local disk so that you avoid fetching the same data on S3. But yes, this is a very important question, and you have to take care about that.
Okay, we'll take one more question because we're running a bit slow. Maybe a bit out of scope, but you mentioned Syndic, can GPUs be used for indexing or search?
Currently, not not currently, and I don't know if I didn't work on this part, so I can't really answer you. But currently, no.
Okay, we're going to wrap up there, but other questions, find Francois afterwards. So round of applause, please.
Thank you very much.
All right, our next speaker is Eric. Let me stop this share. One thing I didn't realize today was all three of our speakers have come from different places in Europe. So we have someone from France, someone from Holland, someone from Spain. Like they've all traveled to London for tonight's meetup. Which I'm like, oh, that's nice. It's very nice of you. What is travel? Travel is that thing we used to do before COVID. All right, you're up. Over to you.
I'm up. Okay. First of all, for the people on the video up there, I'm going to be here every once in a while, but pretty much I'm going to be leaving the picture. So just keep paying attention because I want to come over here and talk to you guys. And I'm also going to go talk to you guys. I think this is a really awesome setup. Last time I was here was a year ago. We were in a completely different building. This feels much more like we're in a university, right? You guys came, I think, to learn, right? That's why we're here. Or did y'all just come for the free pizza? I'm serious. We're here to learn something new, right? I wasn't supposed to talk this month, but they did a call because somebody got sick, I think. I don't know what happened, but they lost a speaker. And I was sitting at my computer working on 2 articles about what you're going to see tonight. And I thought it was kind of funny that I got the chance to present it, and then I flipped it into a talk idea. So you're seeing something super unique. It's brand new. This is also what I use meetups for. I'm super interested in what you guys think of this. I'm also doing a completely different format than what a normal talk would be. Does anybody here know what choose your own adventure is? Have you ever had a talk that's choose your own adventure? I haven't. Have you seen one? Okay, maybe this is like from the 80s, right? That's when they made those books. But anyway, we're going to see how this goes tonight and see how far we get. I try to promise you 3. I have 6 or 7. If we talk really fast, we could get through all of them, but you can also read about them pretty soon as an article. So let's kick this off. When you think about cloud native, that's why we're here, right? And I think it's pretty funny for a meetup. We have like 85 people showed up today. Why is that? This is hard, right? This is not easy, cloud native. You have to constantly be learning. You have to constantly be paying attention. And it feels like cloud native let us down, right? The original picture I used for this is dropped ice cream. That's what it feels like. I got my ice cream. This is going to be great because we have containers. We can containerize applications. It's super easy. Everything is self-contained, nothing to worry about. This stuff scales all by itself. All you can do is describe what it's supposed to do, and we're off like magic, right? It looks like this, super easy. And it is when you're on your own laptop with 1 or 2 apps, right? Super easy. But what they don't tell you is what's happening out there, right? You start connecting observability tools to this stuff. And this is just one example I found on the internet. There's a link in the speaker notes. I'll put all this online at chabelle.org after I'm done. This is just a simple example. One fake app, like a front end thing that just pings this website app. A couple of these normal signal things we're gathering, and you end up with almost half a terabyte of data in 30 days. That's one. We're working on Kubernetes, right? This is auto-scalable, right? What happens when you start spinning up 1 million of these? You're really successful. Things like I don't know what the delivery app is here during the pandemic, but it exploded. Trust me, y'all were calling for food. Bring me beer, bring me food, get me through this, right? That shit went crazy, right? That went crazy with these people. Not only do you have this flood of data sitting in your organization, the average time they keep it is 13 months. Not talking about your banks and stuff that have like laws that require 3 to 5 years. 13 months. And because it's such a complicated environment, it's growing so fast and organizations are swimming in this stuff, they do a policy and they say, okay, 13 months, but they don't think about, hey, we have development environments that you spin up and are gone in a week, but you're keeping all that stuff around. It's just default policy, right? Nobody thinks about it. It's getting better, but it's, so then cloud native starts scaling. Instead of those two nice little containers, it starts looking like this. And if you look close, there's a lot of containers, right? There's also a lot of tools to manage these containers. There's these little teeny things over here that don't even have people in them that are just driving around moving containers from A to B. Sort of like Kubernetes, right? And then you got tools to watch this stuff. It used to be like this when you were watching your stuff. You knew VMs, you knew the size of your servers, they were in racks, you knew what was going on. It wasn't very hard. Somebody spun up a new one, took a week to plug it all in and get it up, get an IP address, start looking at that, add another piece to your waterfall. Not a problem, right? Yeah, this is what it feels like now. And you're standing at the bottom of this waterfall, right? Where are my SREs? There was 30% of you said you were SREs or some kind of DevOps engineer. Who are the SREs? Higher, hands higher. Seriously, 1, 2, 3, 4, 5. That means we have 20 of you that are DevOps guys, girls, right? That's how many said that they were here. 5 of them, those ones that raised their hands, buy them a beer later. They're the ones at the bottom of this waterfall. Am I lying? Am I lying? See, they're the ones that have to put up with this. But it should be possible. It should be possible to do this at scale. It should be possible to make the world have proper layouts, to have good functions, to have straight streets. And the farther you get away with it, it should look like this. You know where this is? Y'all should know where this is. Barcelona, right? You ever walked around Barcelona? It doesn't look like this at Street View. Flying in, pay attention next time. This is what it looks like. They thought about this. There's organization. They're able to manage this. It's not as chaotic as it feels on the street. That's what we're trying to achieve. This is the dream, right? This is the dream. So with that, now you get to choose your own adventure. And I'm taking a big risk here. So ignoring costs in application landscape, focusing on the pillars, or as our friend that was just talking likes to call them signals, sneaky, sprawling tooling mess, controlling costs, losing your way in the protocol jungles, and underestimating cardinality. All of these things are what I see people over the last year and a half struggling with and having problems with, constantly repeating these mistakes. So maybe if we share, talk about them, put them out there, people can recognize that if it's happening in their own organizations. So with a show of hands, who votes for number 1? Only Cheryl. Sorry, Cheryl. Focusing on the pillars or the signals. Got 3 hands, so that's in the lead. Is everybody awake? They already made their choice. Sneaky, sprawling tooling mess. Yeah, that's a really good title. Maybe I should change that. Huh? That's about 10. Losing your way in the protocol jungle. 2. And loud one. 3, 4, 5. Underestimating cardinality. That looks like the first one. We'll come back and vote again. The only tricky part about this is I can't like push buttons while I'm in presenter mode. So we got to try and get down here. Click on that. So there's sort of a demo aspect in this. Then we go up and do this again. There we go. That wasn't too bad. So understanding or underestimating cardinality. Does anybody know what cardinality is? Do you remember at the university, there was a math course you took? Remember that? So I spent years and years and years in the app dev side. When I got into the observability side, they all started talking about cardinality. I was like, man, you got to figure out a different word to use because that just brings back bad memories from the university, right? We got to start digging into our math things again. The idea behind this is that when you do things in applications, when you put metrics out there, when you put signals out there, when you put things out there that you want to be watching, you tend to put labels on them. And metrics are famous for developers deciding, or within a project, somebody asks a developer to do something, to add a metric, to instrument something. And it turns out that that thing is unique. And when it's unique, that means every time it happens, every pod that gets spun up, everything that happens, it just explodes. And so that waterfall goes from a trickle to a fire hose real fast, right? And that usually tends to have a lot of problems, not the least of which is your CTO's budget, right? Because everything, oh, somebody dropped something. And this is a really good example here. This was on a Reddit thread. A guy came on there and was talking about, hey, is anybody using traces and OpenTelemetry and ooh, what's that like and stuff? And this was great. You could just, the sarcasm was just dripping off this, the guy that came on. You can feel how close this person is to burnout, right? Doesn't that pretty much just say it right there? I can't even get him to look at the metrics, let alone traces. And that's not a small organization. Does anybody here work somewhere with 1,000 developers? 1, 2, 3.
Basically resembles something, you know, when you get up in the middle of the night or something, and then you know, hold your head. What the hell am I doing? What is plenty like a book?
Yeah, that's exactly what it felt like. So he's like, when you get woke up in the middle of the night, and you're like, what the hell am I doing with my life, right? That's pretty much what it feels like. This is the frustration that the SREs have to put up with. They know what they want to do. They know how they want to manage and monitor things. They want to turn it into that Barcelona view, right? They're trying really hard. And the engineers and the developers over here, and I was one of them, I'm guilty. You know, we're like, what? Metrics, huh? You know, if it's in my functional description of how I'm going to build something, I'll do that, no problem. But it means nothing to me, right? We have at Chronosphere in 2023, we did an observability report and interviewed 500 engineers and developers and asked them a bunch of questions about this stuff, what they're doing in cloud native spaces, what they're doing with observability. This is really, really freaky, if you ask me. Do you know that you're out there spending 10 hours a week, 25% of your time? That's a whole day on issues, trying to get shit deployed, trying to get shit fixed. It's not deploying, trying to fix something that isn't quite right in the deployment, trying to calm down your SRE because you broke something, that your cardinality exploded, whatever the deal is. That's a lot of time to be spending on stuff like this, right? A lot of time. Doesn't make me happy. And you're noticing the waterfall and the flooding and the being underwater kind of theme and everything here. I don't mean to be depressing, but it is how it feels. This is what these people are dealing with. My colleague who does developer evangelism for us, I took her out of SRE roles. Maybe you guys can relate to this. She had 5 different SRE roles and burned out on all 5. Would take a break for 3 or 4 months to recover and then go look for a new one. And when I talked to her the first time, she was just about ready to go look for a new one. I said, how about you take all those experiences and start teaching people how to not get into that role and into the problems in that role? You know what I mean? And last Christmas, she was sending me texts live, like, this is the first time I haven't been on call. She was so excited that she got to sleep in and stuff on the holidays. This is what it's leading to. Stress is leading to depression, to not feeling happy about stuff. And I think we got to one of the stats was also 22% just wanted to quit. Does everybody here go to work happy? What? What? You better go to work happy, right? You get up in the morning, you spend more than 40 hours a week probably there, right? Even if it's your desk in your house and you're working remote, you're still on a job you got to be happy about. If you're not, think about it. You don't want to be one of these stats. You don't want to be underwater, right? You don't want to be at the bottom of this waterfall. That's not where we want to be. One of the things that can help you with this waterfall, and this is the only, I don't like to plug the product stuff here, so this is just one little quick look. I'm not going to go deep into it and stuff, but what's really important in your observability tools is to have something like this. Something to let you look live at what's coming in. You need to decide what you're using and what you're not, because it's going to be completely shocking to you the amount of stuff you have coming down that waterfall that are totally irrelevant to you. Pod IDs and all kinds of crap you're not interested in putting in a dashboard. Within this control plane, we have the ability to look at this stuff, see live, and automatically show you what you're not touching. Like 80,000 data points that are coming in that you're paying to store, you're not using. No users are touching it. No queries are being run on it. No dashboards are interested. No alerts are set on this stuff. Trust me, if you can go do that in your org right now, you're going to find crazy amounts of stuff. That's all I'm going to say about that. We can go on to the next one. So, what was number 2? The sneaky sprawling tooling mess, I think, right? Is that it? Before I do that one, I wanted to I'm going to go ahead and let you guys pick, right? That's the whole idea behind this. So you said this, right? So kind of a sloppy title, but basically what it's about is this right here. There was this report that came out just at the end of last year, I believe. How many observability tools do you have in your org? Just 2.
So it's probably backend systems that worry about. So let's say.
You think your developers aren't on the CNCF site downloading stuff to play with to look at their see? See? I'm not trying to pick on him or anything. It's just, but 10 sounded like a lot to me. But if you look around and pay attention and think about all the development environments and all the test environments and all the, anybody here an architect? I know somebody said there's an architect, right? So the architect's idea is they guard what goes into the infrastructure, right? What we're building in our complete architecture for our org and our solutions. But how many times does a developer slip something by you? You know what I mean? And it's not that like we do it intentionally as developers and stuff, but something new comes out, makes my life easier. I use it. Next thing you know, it's in there. I actually used to work at Red Hat for quite a while, and I wrote a small tool to help people migrate from a non-standard thing in a BPM tool to a standard thing. And my PM got super surprised, and so did I when this thing rolled out into a button in the UI in the product. Don't know how that happened. It wasn't my plan, you know. So it's very easy to have stuff like that happen. The problem with all these tools is they tend to focus on what he was referring to as signals, what we refer to as pillars. They talk about metrics, logs, and tracing, right? And each one of these tools that you tend to pull in is to solve some problem you have in some project at that moment. It's very short-sighted in a narrow view. The architect was not involved, and somebody decides, okay, we're going to use this. And next thing you know, you got designs of things. And this is super extreme, and I'm not picking on any vendor. This just happened to be a really obvious one I found. Google it, you'll find 100 of these, right? And somebody made them. These are not just demo drawings. You know, somebody is actually in a company looking at their environments like this. This is not helping you get things done. This is flooding you with a bunch of information. This is feeding you the fire hose, and now your beeper's going off and your whole shit's down, and you got to figure out which one of these things is going to lead you to the solution, or what is actually wrong, who do I got to call? That is not how we want to work. Sure, sorry. Collecting bad pictures. I put the lightning in between there on purpose. The whole idea is not logs, metrics, traces. Is to know, triage, and understand. One of the other pitfalls goes into great detail about this. So here I'm not supposed to. This is a good tip for me for the next time to make sure I hit the other one first. But the idea here being when we talk about signals and we talk about technology and when we talk at engineering levels about how metrics are important or how logs are important or how traces are important, you're not talking to the business. You're not talking to people that own the budget, and you're not going to change how things are done. And so the person that's carrying the beeper over Christmas comes in and has to deal with that crap that's been decided at that level. When you start talking about, I need to know what's going on as fast as possible. I need to be able to triage this quickly to get it solved, find out what's wrong, roll that shit back so that we can then investigate and deeply understand root cause analysis, right? That's the kind of language you want to talk, which that means designing how you look at your systems a whole lot different. Only using the information you need, exposing the person that's on call to just what you need to find out what's going on and lead him to somebody to help fix this stuff. That's what you try to design every day. I'm probably, yeah, see, bobbing the head, right? Bobblehead, very much so. So no triage, understand. If you don't remember anything on this talk, remember this one and take this one home. I have articles about this. When you do that, your dashboards turn into things like this, and you decide what goes on here. I'm not feeding you this as a vendor. This is what you're looking at as somebody that owns the orders. I'm super interested in what's going on in my business, in this organization around the orders. And as soon as I see spikes at the bottom like that, like the endpoint durations taking too long, that means latency. That's not good, right? Maybe the orders start slowing down. That's not a good thing. I want to jump on it. I don't want to see 90.7% orders processed. I want to see closer to 100, especially if it's Black Friday, right? So that means that the person that gets called and beeped on these alerts can come in here and go, ooh, bingo, boom. And hopefully that leads to the person they're supposed to call, playbooks or whatever they're using. Make sense? Okay, can't remember what we voted for next. Ignoring cost and application landscape.
That was only me.
That was only you. Nobody likes that one. Focusing on the pillars. You want to go look at the pillars? Sorry? Yeah, but you were the only one that voted for that.
You didn't ask.
Oh, sorry. Did I skip it? Controlling costs. I'm sorry. Did I miss one? Oh, shit. Okay, we'll do that. 4. You thought I didn't do that one, right? Oh, look, I can click without going out of it. That's amazing. Sorry, I didn't know that. All right, how about that? Controlling costs. So what's this one about? This one is real easy, right? So it's quite funny that costs over the last, how many people have been watching online and seeing in the social media the people complaining about different vendors or different cost patterns or how much money they're putting in there? Did anybody see the 37 Signals guy where they backed out of the cloud? Did you see that thing he was writing about? Spent 600,000 on servers. It was a beautiful example. I'm not promoting it either way. I mean, it's their choice, whatever the deal is, but think about this. Nobody cares what they're spending on observability, infrastructure, cloud, or anything, as long as the money they're making is bigger than what they're spending. When it goes like this, people are like, wait a minute, right? And that's what's happening. So many people we run into are doing this or struggling with this problem. One of the first gut reactions in the observability side is to start dropping stuff. Seen that happen? Yeah. Saying, okay, we're going to keep it for a week and then ditch it. But all the people are saying, oh, but you want to keep it because you may need it one day, you know, and something breaks and you got to look back you can only look back a week. You know, you probably can't even look back to the last deployment. You know, it's a little bit rough for the guy trying to do that. So this is a big deal, right? Because everything you keep costs money. And that's the basically all the vendors out there that are selling you observability, that's their earning model. There's no incentive whatsoever to have you aggregate, reduce, drop what you're not using. You'll never hear them talk about that. Have you ever heard them talk about that? They come in there and say, oh, no problem. We can get you to cut down to 80% of your data. I can show you examples where we have demos where 380,000 data points are coming in to draw this dashboard, like the one we were just looking at, right? 380,000 data points are coming in, but you're only drawing it with 300 or about 30,000 or maybe 300 sometimes. It's really insane what you're not using in your data stream that's coming in. So having that control plane is really huge, right? It's really sucks to have all this stuff being stored. It forces you to make bad choices. You really don't want to keep stuff for a week and then throw it on the floor. You really don't want to do that. So do you really know what the cost is of your observability metrics right now in your org? Do you know? You do know?
But some of the queries in Grafana take like a couple hours to run.
Ah, okay. So he's saying a couple of the queries take a couple of hours to run. Boy, if your beeper's going off, do you want to be looking at that? So the reason that this is a great example, the first thing you notice, everything starts out wonderful until that data starts piling up and then you index it, it's all fantastic, but then you got so much that the indexes aren't helping anymore. So you put more nodes in there, right? Put more nodes out there and replicate it until you just can't do that anymore. And then this starts happening. You notice degradation. Things are not responsive. Alerts are fine. They're firing off because things go through thresholds. But when you're trying to look at what's going on, then you're flying blind, or with handcuffs on, or weights around your ankles, or whatever metaphor you want to use. It really sucks. This is becoming a big deal. So there's a very big. Well, I already talked about this, so I don't need to do this. But the control plane idea of finding out what's going on with your stuff coming in and being able to decide what you need and what you don't need is huge. Chronosphere is also one of the first ones to get into FinOps Foundation. Anybody working with the FinOps Foundation? Any FinOps people in your organizations? So I took a slide out because it's starting to get a little bit old now. But in 2022, I was watching, you know, how you do when you're at home working on something, and then in the corner you have an IDC thing on, or a Gardener guy talking. You're just listening, and I caught it out of the corner of my ear. I wasn't even paying attention that much, but she said, she was talking about cloud in Europe, and she said 80% of the companies by the end of 2023 will have a FinOps function in their organization. And the reason I was like, I almost fell off my chair, because they don't ever say 80%. They say like 34, 35%, and then it's like a trend for them. 80%, how did that get past them so fast? The second thing is, this has everything to do with cost, and nobody owns it in an organization. A great example, I was talking to a customer one time, and they had developers that had chosen in a marketplace. You know, you can push those buttons. Architects love those things. You can push those buttons and you can select something. And to complete what they were doing, they put a load balancer in there. The one they selected, the security ops guys wanted a label on it so they could trace this thing. The problem was the load balancers could only do, for each app that was behind the load balancer, you had to put a label on it. They could only do 255 labels. So what did the developer think? Oh, another load balancer, and another load balancer, and another load balancer. So pretty soon they're paying for all these load balancers out there just because security requires them to have labels on these things, and those things weren't software enabled or capable of doing more than so many labels before they had to order a new one. So this got to be a huge part of the bill, and they couldn't do anything about it until they got a hold of the cloud provider and actually got them to fix some kind of patch into it so that they could do that. But think about this, who owns that? It shows up in the budget somewhere up high eventually. Who made that decision? Can you track that down? You blame the SRE? Well, they didn't choose a load balancer, you know what I mean? And that's what's costing them money, not the security. It's all one big mess. So yeah.
In big enterprise, usually people don't focus on such savings. They only focus on success stories, such as I launched a new product in a new country. And if it costs me 2 million to run, who cares? The profit is enough, even if you lose money.
Boy, there's a lot in that one. You basically said everything I've already said. So for the people at home online, let me see if I can condense this. It says people are not concerned about what things cost. They're concerned about launching a product, success. They don't care if it's 2 million to do all that, as long as it's out there and everything's going well. Yes, 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 and no, no, no. Somebody in the pile does care. Remember when I talked about no worries if we're making 2 million and it's only cost me this much to make it. But when it starts turning into this to run it, then we have a problem. And you're seeing the FinOps gain speed and gain traction and gain interest because they're designing in an open organization, just like the CNCF does. They're designing processes, checklists, tooling, for specific cloud providers to help you with your bill, to understand what's going on. And they are where the buck stops as far as what things cost in an org. They own that, right? So your CIOs and stuff are quite happy to have these people on board. Trust me, they got somebody they can blame. CIOs no longer have to leave every 3 years, right? When they get tied up in a knot somewhere and then have to move on. This is really an interesting thing you're going to see more and more of. And I think the observability companies are going to start joining more and more to this because it just makes sense. It's all around the tooling needs to help support these processes that they're designing. We need to have input into those committees and into those processes. Okay, I heard we have 5 more minutes. I think I can squeeze one more in, and you all can ask me questions at the pub. How about that? Really quick before we go further, can you show me your hands? Is this good? You like choosing your own adventure? It's not clunky? Not weird when I gotta like switch? Okay, great. All right, what's the last one you want to see? Focusing on the pillars. So I've mentioned it a few times, so it's probably a good idea to run through this one quick. So everybody's been publishing and talking about pillars. What we should be thinking about are the phases of observability, right? Not the pillars, not the signals, but the phases. Talking the business language. Everybody's been going down to the bottom, talking about technology. And what happens a lot in open source, Love to talk about functions and features and all this kind of garbage, but that doesn't relate to the people you're building the software for. The metrics and the KPIs that they need to track, this doesn't work for them, right? They don't care if it's metrics or not. And the metaphor around this is, if, for example, you have a really nice car, you love this car, you spent a lot of money and worked hard to get it, but it's making weird noises, the engine temperature's going up and there's smoke coming out of this thing. So you zip over to your favorite mechanic, you come in there, and the first thing he does is start dragging out the toolboxes and talking to him and bragging about all the tools he's got, showing you all the cool tools he's got. He can do all this cool shit for. And every time you look outside, your car is smoking even more. And pretty soon it's catching on fire, but he's still bragging about his tools. That is what is like when you're talking about the pillars. Look at my metrics, look at my logs, look at my, screw that. I want to know what's going on, right? I want better outcomes. I want faster remediation, easier detection, and happier customers. For all happy customers, because then I don't give a shit what it costs, right? Customers happy, they come back, buy more. Phase one, know what's happening as fast as possible. That means having just the right amount of information in front of the person that's on call to solve the problem. And I don't care whether you have 1 million services, whatever that person has to do, make sure when he lands in his dashboard to see what's going on, he has just what he needs to know, right? How fast can we get this stuff turned around? I don't want to wait 2 hours. I don't want to wait 2 hours to figure it out. And then you need to be able to triage with very specific information. So when you drill down into that information, it's only the information that applies to what the problem is, not all this other stuff. I don't care if it's 1 log line, 2 traces with 3 spans, and 4 metric labels that get me to the answer. I don't care if it's 0 logs that gets me to the answer. Just get me to the answer now, right? And then you got to be able to understand to make sure it never happens again. And this is known as root cause analysis. And you do this with a cup of coffee, 3 guys, and take 3 days for all I care. But the problem's already been triaged and it's already been rolled back and it's already been stopped, whatever was broken. Yeah. Then you don't end up with this. We end up with this, right? Something to get you going right away. With that, I'm pretty sure I'm over my 5 minutes, right? She's looking really angry at me. All right, guys, thank you very much. I appreciate it. I will see you in May. I'll be back in May.
Thank you very much, Eric. Okay, we are going to go take a break now. So please come back for 8 p.m. when we're going to go into our third talk. So we've got just over 10 minutes. But yeah, see you in a minute. So yeah. Yeah, it's fun. I haven't seen it like that before, but it's good. Anyway, thank you again for doing this.
Don't take my mail away.
Don't take your name. Yeah, I know. All right.
Very nice. Thank you. Can we have a seat? Sure. Very nice. That's quite nice. You said that this software is I did when I was wrong. You're not coming back. Yeah, I mean, it's important. Yes. Oh, okay, all right. Okay, sir. And you come back. You and me. Yeah, very good. Yes. Oh, your mic was a little too far away.
It's like fancy technical physical love, like
we can have a way to demonstrate something visually.
even as like a back end, yeah, look at what you've done for the front end, and it's finished. Like you've achieved nothing on the front end dependency.
Yeah, but no, I mean, fine. Also,
Yeah, how do you like working with the
I actually were you at the what case before? Oh, I joined the no, I'm going to
I want to say I love principle, but also hey, Richard. Hello. Yeah. So I had the last 3 years. I had a proper rest during for the last. I look back at everything. See ya. Yes. I know the food are other, so like might as well come back.
So did you have anything in SRE?
Yes. So
Does that mean you know what SRE is?
I
Would you know what you want?
I think that's the better description, yeah. Yeah, I'm looking over except for sorry.
Very obvious. Is that job? Majority job you work on paint?
Yes. Yeah.
Reality true.
Yeah. So to give system. Well, no, I'm still got the old job back. I haven't noticed that yet. So I'm holding on to that as long as I can. But yeah, they're good at both. Thank you.
I find reluctant not used to security. Think, oh no, one of them. Yeah, that's really.
Oh, oh.
Big one of the small one.
No, that's I
The security goals, something right? Yeah, they were understand. How they get so decent to come down about 10 days a month to something. Yeah, we hope that. Yeah.
Yeah.
Now we've got like all of our, security. Yeah.
Yeah.
That's my choice. We're here to deliver things.
Yeah.
We.
Yeah. Oh, yeah. So, yeah, it's,
Come in, come in, come in, come in. We're going to kick off again in just a minute. Welcome. Get yourself. You might as well start sharing and set up while people come in.
yeah, they do. Well, they got like.
Come in, come in, come in. We're going to kick off our last speaker in 1 minute. Okay. Are you happy to just go through and then try and round up people who's on that side? Okay, thank you very much for coming back. We are going to give a round of applause, please, to welcome Tom.
Hello, thank you very much. I am here to give, I think, quite a different talk to the other two of the evening. Earlier we asked about what everyone does and whether they've heard of GraphQL. The follow-up question, which I'm not expecting a huge yes for, is, has anyone heard of Hasura? Who and a what? Fantastic. That's a no. To a what followed by a no. Perfect. So I'm Tom. I work at Hasura as an engineer. I live in Barcelona, the capital city of observability, apparently. I have to say, when you actually live in the grid, it's not quite as neat as it looks, but it's a lot of fun. And yeah, I suppose I'm here to tell some stories. So in the good old days, when we wrote very simple systems, websites looked a lot like this, which was a user comes to our website and asks the server for the website, and the server says, here is the website. And now we have a website. Simpler times, weren't they? For anyone who hasn't worked in web development, if you're looking at this and thinking, the good old days, you're probably about old enough to be sort of out of touch with the music of the youth now. That's probably the age. Yeah. Sorry. And then we decided, actually, there's a better way of doing things, which looked like this. This is sort of your, if anyone remembers, Backbone, Marionette. This is sort of where I got into web development. If you remember this, you're maybe the age where sometimes you wake up with a bad back just because you slept wrong. This is sort of the age we're looking at. And the way this worked is a client asks for a website, and the server says, here's some of a website. And the client says, well, where's the rest of it? And the server says, here's the rest of it. And there's this sort of back and forth, and we start to hear about technologies like Ajax, as it was back then. And then things started to get a bit more complicated. This is about the time I checked out of front-end development, which was single-page apps, which is the user asks for a website, the server says, here are the tools to build a website for yourself. And thus the client does it at huge cost to your laptop's battery. And this is sort of the way things were when things like React kind of came to be. And then I am told by my colleagues who work in this world that things have moved on since then. And now we have this thing where a user says, can I have a website? And the server says, here's a website. except it's not the website. It's the website as it might have been 5 minutes ago. But if you want to know what it looks like now, you're going to have to come and ask, because this is just a cached version we keep around just in case. So things are getting complicated. I'm not here to say which one was best. I'm not here to lament the loss of the good old days. But I am here to point out a sort of parallel if you're not from the front-end world, which is in the good old days, if we zoomed out, backends looked like this. You had the bit that does the thinking and the bit that does the storage. So you have your app probably written in PHP or Ruby on Rails, and you had a database, which was probably MySQL or a text file, and everything was fine. And then we decided, no, we need a better way. So along came microservices, and I think for a lot of people this is still very much a reality, which is I have data, but I have lots of different kinds of data, and different kinds of data require different access policies. They require different technologies. So I'm going to separate them all, hide them behind a sort of interface, which I'll call my microservice. And then when I want to write the thing that actually does the thing that people pay me to do, it's just going to go and talk to the ones it needs. And you end up with this beautiful web that you show to higher ups in the business, and they go, ooh, and that's how you justify your pay rises. Things have changed, though, because now we've said, actually, keeping all this data separate is a terrible idea, because what if it goes out of sync? What we'll do instead is we'll put it all together in some sort of event stream or source of events, we should say, just to be general. And perhaps each microservice will have its own sort of local projection or representation or even state, but it's all sort of coming from this unified pool, this lake of data. And again, this might be the way the world looks. This is not necessarily what I'm suggesting is better or worse. The thing I want to talk about today is why does change happen? Why can't we just have the good old days when everyone was very happy and you could leave a USB stick on the train and it was local news, but it wasn't national news. And of course, we all know this because we work in software engineering, and we have SREs with us. We have people who architect huge systems, and there are a number of reasons why we can't just keep things the way they were. The first is that the sort of landscape of tech business has changed somewhat. And back in the good old days, you could run a little website and that was fine. And since then, we've sort of had these huge contenders in the market emerge. AWS is one, Microsoft, Google, these sorts of huge companies that in some sense own a lot of the internet. And now the game is, how do I talk to them? How do I interface with something bigger than me so people can discover me because they don't just stumble upon me anymore? And so this has meant we want things with a sort of more explicit notion of an API. We want our data that is internal to be externally available in some hopefully responsible and structured way so that people can talk to our services. The other thing is we just suddenly decided to start logging everything, didn't we? We love logs. We love tracing. We love events. If you've done any time in the front-end world, you love amplitude or something like that, where you just, every time someone clicks, that's data, and it goes into a big pile, and you generate reports with it. You love it. So we have a lot of data, and we want to architect systems such that we can produce a lot of data. Because the other thing that is quite interesting is we started selling that data as the product. I'll tell a story a bit later, but I used to work for a mortgage broker, and the purpose of the mortgage broker was not to do anything but broker mortgages until we realized that all of a sudden we knew a lot about mortgages. And then the business model changes a bit, because actually our knowledge of our domain and the data we've gathered becomes just as valuable as the thing we were trying to do anyway. So, as well as these changes, and as well as these sort of driving forces, we also see some kind of organizational patterns emerge. I've drawn the line here. It might be slightly different where you work. People might sit either side of the line. But I sort of divide, at least the companies I've been at, into kind of product teams and data teams. So your product teams are the ones that say, I would really like to be able to do this thing. And your data teams are the ones that say, that is such a terrible idea, it should never see the light of day. And you get this kind of tension between the two, where your product team's responsibility is to kind of make the dreams of your users come true. It's to think big and creatively and have these grand ideas. And the job of your data team is to stop the entire website falling over at 2 o'clock in the morning, and to make sure that if you say something, it's true, and to make sure that people can't see each other's personal data, and all these sort of responsibilities we have. So it would be nice if they separated this cleanly, but of course they don't. We know they don't. It already looks like a spider's web, and we haven't even started. What if I want to add things? What if, for example, I have a service for users, and my product team says, I really like it, but I'd also like to know every user's GitHub profile. Do I patch the service that provides users and potentially risk something breaking? Do I spin up a new service that looks a lot like the old one, but now has a GitHub profile attached to it? All these sorts of convoluted examples I can give where my product owner doesn't understand why I can't just do the thing. But there are really good reasons why it's not just as easy as copy pasting or adding something in. So you get this tension, which, you know, when applied correctly is quite healthy, this back and forth. But we don't want to make it any worse than it has to be, I suppose. So I lied. I am going to tell you the right way to do it. I'm joking. This is our attempt within Hasura to kind of come up with an architecture that I guess could encompass every architecture we've seen thus far. And in the process, hopefully kind of at least propose a generalization of the state of the world, as it were, which is almost identical to this diagram, except we put a box in the middle and drew one line from each one to that box instead of lots of lines. And today I'm going to talk a little bit about why I feel we're justified in doing that and calling it a success. And I will say as well, I'm not going to talk about or demonstrate anything that isn't entirely open source. So it is a sales pitch, but it's sort of a friendlier one. You can do all this for free at home. Do whatever you like. So marketing. A supergraph is an architecture and operating model to build and scale multiple data domains as a single graph of composable entities and operations. If you are an engineer, a supergraph is just a way of saying, basically, I have a lot of dependency graphs. I have this service that depends on these things, this service that depends on these things, this service that depends on these services. And if I sort of drew all them on the same piece of paper, what I would have is the thing we call the supergraph. This is just the full picture of everything that's going on. When we talk about a supergraph as a thing you want to build, however, we have a couple of, I guess, rules and guidelines in mind. The first is that there is a very specific and well-documented explanation as to the protocol of the blue and the orange lines. They speak a common language. Every front end that wants to talk to the API speaks a common language, which is GraphQL. And every data source that wants to provide something to that supergraph speaks a common language. There are lots of candidates. Apollo is another company that does federation of GraphQL. We'll talk a little bit about the difference between that later. There are competing standards. I'm not here to tell you which one to use. But needless to say, when I talk about a supergraph, what I mean is everything plugs into it using a common language. The thing that I think makes this more interesting than just an API gateway, which is kind of the obvious solution here, is this composable point. What I mean is, I have two services plugged into my supergraph. I should be able to join data from one to the other. I shouldn't be limited to, here's a query that talks to this one and this one. I want to say, get me all the users from this query and also get the names of their dogs from over there on another service. And that should be doable within the language of this supergraph. So when I say composable, I mean these things don't necessarily sit side by side. There's also a notion of a sequential computation. I want to get this data from this service and then feed it into this service to produce a final answer. So specifically, how did we do it? Because we built one. Ta-da! The way Hasura works is every time you send a GraphQL request, we compile that request specifically and individually into a query plan that serves only that request. It is not generic. We don't have sort of individual resolvers for individual fields. You send a request and we compile that request into a plan. That plan might just talk to Postgres, in which case, great, we compile that plan straight to one SQL query. It might talk to Postgres and Kafka, in which case, great, we compile the first step to a query, and then we feed the data from that first step into the second data source to produce the data that we want. We kind of extend this idea a little bit by saying, actually, we'll generate sort of CRUD endpoints and the boring ideas for you. So if you say, I have a users table, I would like to be able to insert, update, delete, and look at them, and you tell us who's allowed to do what, and some, I guess, predicate filters about, I can't edit a user who isn't me, for example. We can take care of automating all that. And through this model, we kind of define our version of authentication. You may plug your own in as well. And crucially, you only write code to handle requests that aren't sort of a template request of something else. So if most of the work you do is CRUD, you don't have to do any work. If most of the work you do is sort of, it's kind of CRUD, but then once I've created this user, I want to send this email to whoever, you write the bit that tells us how to send an email. You don't write the bit that tells us how to insert the user. So it's sort of minimizing the amount of work you have to do, because you only have to do the bits that aren't very mechanical and sort of the code you'd write in every job. The protocol by which we implement this is entirely open source and available, and it is being actively worked on. This is how we build our products. It is an open specification. Oh, and I have a demo. Yes, okay. So here's a GraphQL query for those who've never seen GraphQL. The thing that makes it interesting is I have a bunch of, let's call them collections, which you might think of as tables in a sort of regular database world. But what makes them interesting is if I say, give me the, I don't know, title and album ID of every album in my database, I'll get a response, hopefully. I got an email just before this from Neon. Oh, yes, absolutely. I got an email just before I started this from Neon saying they're about to do scheduled maintenance, and both my Postgres servers are running on Neon, so this could break at any moment. So here we have a query. We've asked for the title and album ID of every album, and we've got them. And to prove I'm not lying, we can ask to analyze this query, and you'll see some fantastic JSON munging that really just asks for those things and nothing else. There is nothing generic going on here. We're not asking for select star and then getting rid of the ones we don't want. We have compiled this query into that SQL, and we can even delete that, and we can run it again and hope that Neon looks on us kindly. And we have a different query. It's a GraphQL to SQL compiler, in a sense. We can do things clever. We can do clever things. Sorry, I've been speaking nothing but Spanish for a while, so I can't speak English anymore. So here we had fewer results. Why did we have fewer results? Well, we said this time I want to send this request in this user role, which is a thing I made up. You can define your own role-based permissions as you like. And we can see that actually user has some special permissions. What are those special permissions? You can only select rows that whose artist matches your ID. So my user ID is 1, so I can only get albums by AC/DC. So that's very good. It's a GraphQL to SQL compiler. The thing that makes this interesting, or makes it worthwhile for this talk, I'm sorry, I have to wait for the little zoom thing to disappear. There we go. And then click very carefully underneath it. The thing that makes it interesting is I have 2 databases here. The first is a Postgres database with an album table in it. And the second is a Postgres database with an artist table in it. These are different data sources. And it would be sensible, wouldn't it, if we could say, for every album, get me the title and the name of the artist who wrote that album. Now, look at that. So what we've done there is we have run a query across two different data sources. Specifically, we've run a query on album to get the title of every album we want and the artist ID. We've then used the fact that behind the scenes, I said these two things are related, to go into the artist table in the other database to find out which artists we need in order to satisfy this sort of hole in the query. So the idea is, as we kind of can currently plug a new version of Hasura, the idea is that we have this open specification that says not only how do we get data from your backend, be it Postgres or MongoDB, or there's a Neo4j one being worked on, whatever it is, how do we get data from your service, but also how do we join between data from your service and another service in a way that is performant in a sort of regular language. And if you can do that, if you can say, I can join from any service to me, then you can justify having one line from each to the supergraph. By all means, please go check out the spec. If you look at it and think, well, you haven't thought of this, this would never work, blah, 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 please message us. This is an open standard. We are working on it. There are bound to be things we've forgotten, and we would appreciate any feedback. Was it a lie? No, you can try out Hasura Cloud. It's free. All the things you've seen today were open source. Hasura Cloud is not, but you can play with it. You can get your first $100 free. I couldn't tell you how far that gets you, but needless to say, it's enough to run any of the demos that I've talked about today. We also have a Discord, which is largely for the open source community, so feel free to log in and ask questions. V2 was written in Haskell, V3 was written in Rust, so that's already a breeding ground for arguments, so feel free to get involved. And other than that, thank you very much.
Again. All right. Thank you very much, Tom. Any questions? You can type, you can have the orange box. Hold on, catch. Oops, okay, not bad.
Right, my question is quite a simple one, actually. It's relating to the two Postgres instances you are running. One to basically identify the artist, the other one to basically supply the music. Now, I personally think it was overkill to use GraphQL on this compiler, basically translating to SQL. Why don't you use a join, in and outer joins for primary keys? SQL.
These are two different databases sitting on different services at, let's say opposite sides of the world. If they were running on the same,
okay,
we would compile the query to a join. As long as you're within the same data source,
yeah.
At least with SQL languages that have enough support for things like JSON features, et cetera, one GraphQL request becomes one query. And we do that with joins and with sort of JSON functions to aggregate things. But as soon as you're talking about sort of cross-source joins, we have to get involved. For example, one of your data sources could be a CSV file, and it has no notion of joins, so we have to come up with one, I guess. Yeah.
Thank you.
Coming back.
Anybody else?
Oh. What about state? Is that captured anywhere within the supergraph?
What about state? So the protocol we have designed is entirely stateless. Sorry, I should be clear. The protocol is stateless. Some of the connectors might not be. A good example of this is like Postgres connection pooling.
Yeah, sure.
There is state, but the requests you make are independent, isolated. So
any caching, you'd kind of go higher up.
Exactly, yeah. And we can talk about sort of caching as a connector that sits in front of another connector, if you like. But the aim is when at least our engine asks, let's say Postgres for a particular query, it also sends with it all the relationships that it thinks exist in that database, so that the connector never has to remember anything. It's an entirely stateless thing, which is a deliberate choice for scaling effectively. You can always just add more because none of them know anything. You can have as many as you like.
Do I just chuck it back? Or-
We're getting very confident with the throws.
Yeah. Is that
Ooh.
Just a quick one. How do you handle deduplication? Let's say two services are fetching more or less the same kind of data. How do you prioritize? One might be providing a slightly different set of data, but still provides what you want. How do you tell, how do you choose?
So at the moment, the cop-out answer is that's up to you. Like the thing we aim to do is you tell us which fields in a GraphQL schema would go to which data sources, and beyond that, we sort of don't get involved. Unless I guess a more specific example is like load balancing or something like that, in which case it's kind of a separate system, I suppose. We have load balancing as a feature you can pay us for. Sorry, it's not open source. But if you want to talk about, for example, some sort of very very complex free text search system where you sort of have this notion of costs of queries or likelihood of something being up to date or something like that. It's not something we build in. However, a feature I haven't talked about today is we have this notion of native queries, which is if you can describe to us how to resolve something to the kind of query language of your data source, we'll just defer to that whenever anyone asks for it. So for example, we have people who have, I don't know, a comments table, but they say, I only want to select comments that have happened within the last 10 minutes or something. We don't have like time windowing, but you can write that as a query. And so every time someone asks for comments, we'll call that query instead of going to the table.
Just a quick addition. As you mentioned, load balancing, something like Canary would be really nice.
Yeah.
Is that an idea?
Yeah. Well, the spec's open source.
Thank you.
Just sensible.
all right? We've got a question here as well. Apollo federated graph versus supergraph.
Yes. So for those that don't know, Apollo is kind of the other one that when we explain what Hasura does, they go, oh, like Apollo. I'm a little out of date on this. So what I'm about to say might not be true. And if it is a lie, I'm sorry. Federation does not include the notion of joining across databases, as I talked about. This kind of composability requirement isn't a necessity, whereas the spec we're building requires it of connectors. In fact, it's something we require them to declare that they can do. So to come back to the artists and albums example, if my artists are in this table, my albums are in this one, federation doesn't help me because I have to know all the artists before I can ask for their albums. Whereas if I have, I don't know, if I'm populating the homepage of a website, I want to get latest news from this source and I want to get the user's profile from this one. Federation's fine. Those two things don't depend on each other at all. So that's my understanding based on the information I have. The Apollo landscape might have changed, but at least last time I looked at it, federation is a much more sort of, it's a router effectively. It's a sort of GraphQL flavored router which says this request goes to this subgraph. I believe also you federate GraphQL APIs. You don't federate data sources. So you say, I want to build a GraphQL API in front of these GraphQL APIs so people think it's one API. Whereas what we do is say, we'll go straight to the data source. I think that's a fair answer. If it isn't and someone in the room is seething, please come talk to me afterwards, because I'd love to know.
One more, hold on.
No, I want a simple question because you are speaking about data sources.
It's for the recording.
Yeah, okay.
People on the back.
Hello, Marcus here. You are talking about the data sources and databases linked with the microservices, but
I can repeat.
So what I want to ask is, in some ecosystem, we have Kafka, for example. How do you manage that with this Supergraph application? The Kafka and all the stuff sometimes linked with Kafka, like domain-driven design and those stuff.
Yeah.
Not always you are using Kafka. But...
So if I understand your question, it's does a data source like Kafka make sense in the language we're talking about here?
Yeah. Okay.
As a kind of weirder example of a database. That's what we're trying to figure out. When we talk about data internally, what the spec actually describes is our intermediate representation of a query. So we don't talk about tables, we talk about collections. They could be tables, they could be event streams from Kafka, they could be regular old SQL queries, they could be REST endpoints. We're trying to describe data as abstractly as possible so that when we then go to the Kafka connector and say, I want this data from this collection, the Kafka connector can say, oh, what you mean is you want me to sync some events from this stream and aggregate them and return them. It's a talk in itself. I think it's fascinating, this spec, because it works a lot better, I think, for queries than mutations, i.e. reads rather than writes. It's something I'd love to talk about because it's been a real challenge to say, how do you describe a write in a way that includes appending to a text file, inserting in a Postgres database, adding an event to an event stream that's going to get projected into a read model later on. Like it's not very obvious how mutations work. You also all of a sudden have to care about the order of events, transactionality, what happens if there's an error. All of these questions are, I think, more exciting than the query side, which is ultimately quite straightforward. I'll talk to you in terms of, you have this collection of data that I know has these fields. I would like these fields on it where this filter is matched, and you're free to do with that whatever.
Yeah, I mean, that's what I was meaning at some point. I mean, some data is not coming into the databases. They are going straight forward to the Kafka streams, for example, and even something I was working before, it was using big data, which at some point is easier than Kafka for fetching from your application. So that's the reason I was asking that, how you can manage the Kafka events, which is at the end of the day data, which is going to be in the system for a while, maybe, but it's not persistent like the database.
I would say go look at the spec, because off the top of my head, I can't think of anything that would conflict with that idea. Like we don't have properties we assume, like if you make this query twice, you'll get the same result, which would fall apart when you have an event stream. Okay. So I would say have a look, but I think the query side's pretty good. The mutation side is definitely a work in progress, but I think we can talk about Kafka streams and relational databases and document databases in a language sort of abstract enough to capture all three.
Let's stop there. Thank you. Really?
Pretty good. All right. Cool. Another round of applause, please, for Tom. Thank you. All right, that is it. That wraps us up for tonight. Thank you so much all for coming out. We'll be back again on the first Wednesday of the month, so February 1st Wednesday. Come along to the conductor if you want to hang out for a little bit longer and get some more drinks and stuff. Otherwise, have a good night. Please remember to leave these badges, the blue fobs. Thank you.